today's video we're going to talk about manual milling machines. This is what they call a knee type mill. This is where the knee on the machine actually travels up and down. Milling machines primarily have rotating tool bits and stationary parts that are either clamped to the table or held down in a work situation. You probably use a vise a lot. With the vices you can clamp either square parts, rectangle parts, round parts. If you do table setups, which we'll talk about a little bit more later, you actually put clamps in these grooves on the table and clamp parts down. So just like everything else we do in the machine shop, we like to talk about safety. Obviously, keeping a clean and organized work area is number one. Everything has to be organized, otherwise you're tripping over hoses and cords. If there's a lot of material or debris on the floor, oil on the floor could be a slip hazard. So if you have any of those conditions, please correct them while you're working. Just make sure you're operating everything safely. When handling cutting tools too, you have to be careful. On the tips of the cutting tools, they're generally sharp, so you don't want to be putting the cutter right in your hand. You want to hang on to the cutter by the outside of the cutter. Next, let's talk about machine controls. On a milling machine, it looks familiar to some people because they've seen drill presses before. It does have a drilling feature where you can extend and retract the quill on there, and you can drill holes with it. So a lot of students are more familiar with a milling machine just simply because it looks like a drill press they've probably used in the past. How a milling machine is different from a drill press though, is that the table moves underneath the tool. So the tool will rotate like it would in a drill press, but the difference is that you can move the table underneath the tool and create different features. And they could be very simple, plain things like milling the outside of a block, or you could be doing something with drilled holes with counter bores, or doing some kind of a groove. So this is kind of a more basic project that we do. This project started out on a lathe and they made it nice and round, and they did the grooves and they got the ends done. So the only operation on the milling machine was to put the hole in there with the threads. So you can do counter boring, drilling, and tapping on the mill. Now this one was a more complicated part that we made. As you can see, they have a lot of contours. Now typically on a manual machine you won't be doing something this ornate or this complicated. The uniqueness of this machine is that it can be a manual mill or a programmable CNC machine. So let's talk more about the controls. We have the quill. You can extend and retract the quill. So this is called the quill handle. Over here on this side we have the quill lock. So if you have the quill extended, you can lock it in that position so it doesn't move. Everything we do on the mill, you want to have the quill all the way up and locked. That keeps the spindle up inside the machine, keeps it short, keeps everything nice and strong. That is one thing we like to teach, is to have short, rigid setups. If you had your quill extended all the way, you have this much sticking out of your machine, the cutter is sticking out of there yet, it's going to be very unstable. So most of your work, you want to keep the quill up tight and locked. The other thing we talk about is the Y hand wheel. Now the Y direction, everything on a milling machine is located by the XY coordinate system. You probably learned that in math class. So you have the Cartesian coordinate system that deals with X and Y. So this hand wheel moves the Y axis. And if you look at the screen, you can actually see the numbers counting or keeping track of our position in the coordinate system. The other handle is the X hand wheel. That'll move the X axis. So that moves the table left to right, and the display will keep track of your position. If you have a machine that doesn't have a display, there are micrometer handles on here as well, little dials that tell you where you are. They count from 0 to 200, so every revolution would be 200 thousandths of an inch on this machine. On this machine they also have a Z-axis. Now Z is typically perpendicular to X and Y. So on here the quill is the Z-axis. If you notice, the Z's numbers change as the quill extends and retracts. Now this machine also you can raise and lower the table. So this handle here, if you go counterclockwise, it lowers the table. Now that's a lot slower moving, so it's maybe hard to see in the video there that it's moving. If you go clockwise, it raises the table. This handle is only 100 thousandths per revolution, and you may have noticed it doesn't show up on the display. So any movement you make raising and lowering the table, you have to keep track of on the dial. If you want to re-zero the dial, you have to loosen the lock collar. You can rotate the dial without moving the table. Now it's just the dial that takes the readings is moving. Lock the dial, and that would be your new zero. So for every axis, there's a hand wheel to move it. For everything that moves, there's also a clamp. So these two levers here are actually your x-axis clamps. If you clamp those, you turn those clockwise, that tightens it up. Now you can't move the table on X. Underneath here, there's actually the y-axis clamp. If you clamp this one, that clamps the y-axis. The z-axis clamps, there's actually 3 of them. For light-duty machining, we just use the one on the front. If you turn that clockwise, that clamps the z-axis. If you're doing some heavy-duty machining, there will be clamps back here as well on the back of the knee. So if you're doing a lot of heavy cutting, you want to lock these as well. There are other controls on the top of the machine, what they call the headstock. There's the spindle brake. So if you're running this machine, this would be the brake. After you shut the machine off, you engage the brake, it stops the spindle sooner. On this side, there's a high and low for shifting it from low or high gear. Now in low and high gear, your speeds are displayed in these 2 windows. We have a turtle or a rabbit on this machine. Some machines say low and high. Here we have to assume that the turtle is slower than the rabbit, so that signals low, and this is high. I have one more speed selection here. So while the machine is running, I can adjust this dial here. Now you can probably even hear it speeding up. And in the window, it displays what speed you're at. So right now, I'm in low gear on the gearbox. So if I look at the turtle for low gear, it says I'm going 240 RPM. If I rotate it the other way, it slows it down. Now I'm back down to 100 RPM. Now up here is the control box for this machine. If you have the machine in high gear, you want to make sure you select high gear for forward rotation. So high gear on the gearbox, high gear on the switch will give you forward. If you're low gear on the gearbox, you'd make the switch to low gear. That would be forward rotation. If you do the opposite, if you have low gear on the gearbox and you switch to high gear on the switch, that will give you reverse rotation. And the reverse is also the same. If you're in high gear and you have this switch to low gear, that would give you reverse rotation. The other thing worth mentioning is when you're shifting from high to low or low to high, always make sure your spindle's in gear. Because there is a position in the middle called neutral, and we'll be using that later as well when we start using indicators where we have to rotate the spindle by hand. So when you put it in gear, make sure it's in gear by rotating the spindle. When you heard that clicking sound, that's actually when it jumped into gear. If you were to start the machine with it out of gear, you would hear a terrible sound, and that's the gears grinding inside the head. So always make sure it's in gear after you've shifted from low to high or high to low. So when I push spindle start now, it will actually start the machine. So off stops the machine. The other switch we have here is the coolant on this one. This one actually has a built-in coolant system. You can turn it on, either flood or mist. The other switch you've seen on probably every machine you ever ran, they call it an emergency stop. If you have this in gear and something's going wrong, you can either shut it off with this switch or you just push in the emergency stop. The next thing we should talk about is this switch here. It says in and out. Now what that does is it activates the drawbar. When you put something inside the machine, this machine has an R8 taper, so you need to use an R8 tapered tool. You notice there's a keyway on there. That keyway has to line up with the key inside the spindle. So you might have to feel up inside your spindle and you'll find a little bump in there. That has to line up with the groove on the tool. After you pushed it up in there by hand, you have to hit in. In will tighten the tool. So once you have a tool in there, to release the tool, you have to push out. So hang on to the tool, otherwise it'll fall out and hit the table. If it hits the table, it puts a dent in the table, and you use a little bit of precision there. So you want to make sure you catch the cutter. So hang on to the cutter and push out. Couple things to talk about here. Before you run a machine every day, make sure it's lubricated. Everything on the machine runs on the ways. The ways are two precise surfaces, and they're made out of similar materials, similar metals. One's usually cast iron, the other one is steel. So for that to glide smoothly and accurately, you want to make sure that there's a lot of lubrication on those ways. Most machines have a lubrication system on the side of them. This machine actually has an automatic lubrication system on it. So this one is worry-free. If the machine is on, that's activated by a timer so that it automatically lubricates while it's running. On the machine, there is also little cups where you can put oil in on the headstock. These should be oiled occasionally as well. So that concludes our first video.